Hello, and thanks for clicking on this next Algebra 1 production. Today we're going to be talking about systems of linear inequalities. So the other day we talked about how to graph a linear inequality, right, in 2 dimensions. Today we're going to talk about how to graph systems of linear inequalities, which, as you might be able to figure out, are 2 inequalities on the same graph. So let's get started. Let's take a look at the first one here, which is labeled number 2. It wants you to graph these 2 inequalities. Now, it gives you 2 pieces of graph paper. We're going to graph them separate first, and then we're going to see what they look like on the same coordinate plane. So let's start with the first one here. We want to graph 3x minus 2y is less than or equal to 2. So first thing we want to do is solve for y, right? We want to put it in slope-intercept form. So we have a positive 3x. Let's subtract it and move it to the other side. So now we have negative 2y is less than or equal to 2 minus 3x. And then we're going to divide everybody by negative 2. All right, we'll get rid of this in a minute when we have our actual answer. And we have the equation of the line is going to be y. Now we divided both sides by the same negative, so we have to reverse this inequality sign. It was less than, now it's going to be greater than or equal to negative 1 plus 3 over 2x. Okay? All right, so let's write that down here. Y is greater than or equal to negative 1 plus 3 over 2x. That way I can erase all this stuff so that we can use it for our second line. Give me just a second here to erase it. Okay, so let's talk about how to graph this. So we have it in slope-intercept form. Let's start by graphing the line. It's greater than or equal to. That means it's going to be a solid line. All right, so let's start with our y-intercept negative 1. We'll go down 1, and from here we're going to go up 3 and 2 to the right. Up 3 and 2 to the right. And we could also go down 3, 2 to the left. Down 3, 2 to the left. The line is going to be solid, okay, because it's equal to. So that means the points on the boundary or the line itself are answers. All right, and now it says y is greater than that. So we're going to go to that y-intercept that's right here, and y is greater than the line. So greater than is above the line. So we're going to shade everywhere above the line in blue. All of these points are all solutions above the line. Y equals negative 1 plus 3 halves x. Okay, so let's take a look at the other line. It just says y is greater than 3. All right, so this is an easier one to graph. The greater than sign, okay, not equal to, means a dashed line. So we're going to draw a dashed line, and it's going to be horizontal. It's going to go through the y-axis at 3, and it's going to be greater than. So it's above, okay, greater than 3 is up here. All of the points above that dashed line are going to be shaded in. They are all solutions to this inequality. All right, so that's what my 2 lines look like, okay? Or what they would have looked like had we done this the other day, right? We just graphed them both separate, okay? So now, what if I asked you to put them both on the same coordinate plane? So let's start, we'll do them in 2 different colors. I think it was, yeah, it ended up greater than or equal to negative 1 plus 3 halves x. Okay, so let's go graph that one again. So down 1, make a point. Up 3, 2 to the right. Up 3, 2 to the right. Or we could go down 3, 2 to the left. Down 3, 2 to the left. It's a solid line because it's equal to. And y is greater than or equal to, so we're going to shade above this line in blue. All right, so I don't want to go too crazy with the shading because I want you to be able to see both the lines at the same time. So now let's come over here. We'll pick a different color. And it says y is greater than 3. So we're going to have that dashed line that goes through the y-axis. Okay, and then y is greater than 3. So we're going to shade above the y-intercept in okay, that orange line here. So let's shade that all the way above. Okay, anywhere above the orange line, you're going to shade in orange. Now, what you can see is, and we'll make it a little bigger over here. Here was your dashed line. And then you also had this solid line that went through it, okay? It creates 4 regions, right? The X creates 4 regions. 1, 2, 3, 4, okay? In 2 of the regions, only one color is shaded in. You have the orange region here. We have a blue region here. We have nothing shaded in down here. And in this region, we have both colors shaded. So my solution is going to be where both colors have been shaded in, which in this case is going to be region number 1. Okay, that's where my solutions are going to be. So what I'm going to do is I'm going to erase anything. Oh, never mind. I'm going to erase the whole thing. So much for that. Okay, I'm going to go ahead one more time and graph these real quick. Oops. And then we have the other line, which is, I know everybody's laughing at me. That's fine. You're allowed. Get rid of that. And I'm going to shade in, let's say, green, this region. This region was shaded on both lines. So my solution is in the green region. Okay, that's where my solution is. All right, so now what we can do is we can define this stuff that we have here. A system of inequalities. A system of inequalities is 2 or more inequalities with the same solutions. Okay, the solutions make both of the inequalities true, just like in a system of equations, right? You get that one point where the 2 lines meet. It has to work in both of the equations, okay? All right, so now we're just going to try a couple here, and then we're going to be all set. So to graph a system of linear inequalities, okay? Graph the boundary lines of each inequalities, dashed lines, remember, okay, not equal to, solid lines for equal to. You're going to shade, right, on each line, okay, shade on each line, and then the intersection, right, where the 2 colors come together, the 2 shades come together, is the solution to the system. Okay? All right, so let's go. Here we go. Here's the first one. I want you to solve. Okay, y is less than or equal to 3, and x is greater than 1. So y is less than or equal to 3 is going to go through the 3. It's going to be a solid line. All right, so it's going to go halfway between the 2 and the 4. Okay, remember it's going to be horizontal. It's got to go through the y-axis. Here's my y-axis. It's got to go through it. And y is less than or equal to 3. So I would shade underneath the line. Okay, so I'm going to put this little arrow here to say I'm going to shade underneath the line so that I only have to shade one time. Okay, and I'm only going to shade my final answer at the end. So now x is greater than 1. That's going to be a dashed line. It's got to go through the x-axis at 1. And x is greater than 1 gets shaded to the right. Here's all the numbers that are greater than 1 for x. 2, 3, 4, 5, 6, 7. So we have some red shading that's down here, everywhere below the red line. And then we have our blue shading is everywhere to the right of the blue line. So my solutions lie where the 2 shades meet, which is going to be in the bottom right-hand corner here. So let me erase all this. Okay. And there are your solutions. Everything in the bottom right, this area. Okay. All right, so that's it for that one. Let's see if we can do the next one a little bit differently. Okay, so here's the next one. I want you to graph y is less than or equal to negative 1/2 x plus 3. So we'll do that in blue. So my slope is going to be negative 1/2, and my y-intercept is going to be 3. So I'm going to start by going up 3, making a point. Now from here, I'm going to go down 1 and 2 to the right. Down 1, 2 to the right. Or I could go up 1, 2 to the left. Okay, and it's going to be solid. Okay, because it's greater than or less than or equal to. So I'm going to draw a solid line here. There we go. And it says y is less than. So y is less than, I'm going to shade below down in this region here. Everything down here would be shaded. All right, but I'm not going to shade it in. Okay, let's go to the other line. The other line they want me to graph is y is less than 1/4 x. Whoops, just less than. So that has a slope of 1/4, and the y-intercept is 0. So I'm going to start on 0, and I'm going to go up 1, 4 to the right. Or I could go down 1, 4 to the left. It's got to be a dashed line, because it's not equal to. And for this line, I'm also going to shade below. Find the y-intercept and shade below it. So now, I'm shading below the blue line, which would be all of this. And then I'm shading below the red line, which would be all of this. So my solutions are going to be in this region down here. It's both below the red line and below the blue line. All right, both below the red line and below the blue line. All right. So that's shading your solutions without actually shading both. You can shade both if you want. There's nothing wrong with that. Okay. I just think it's a little easier so that you don't have shading going all over the place. All right. But if you want to shade in both lines, you can, and then find your place where the two shades come together, and then erase the other stuff. That's okay. All right. Let's try this one. So let's go for x minus 2y is less than -4. Okay, so this has to be solved for y. So we're going to subtract x on both sides. -2y is less than -4 minus x. We're going to divide everybody by -2. And we get y is, now we divided everybody by the same negative, so the sign has to get switched. 2 plus, there's really a 1 in front of this x. 1 over 2x, right? We have a negative divided by a negative, that's a positive, and then the 1 divided by 2 is 1/2. Okay, so my slope is going to be 1/2, and my y-intercept is going to be 2. So I'm going to start by going up 2. From there, up 1, 2 to the right, up 1, 2 to the right, or down 1, 2 to the left, down 1, 2 to the left. My line is going to be dashed because it's not equal to. And if we go look at the one in slope-intercept form down here, it says y is greater than, so we would shade above the blue line. So above the blue line is going to be shaded in blue. All right, let's go for the other line. The other line is y is, we'll see, yeah, we should be able to fit it in here, greater than or equal to -x minus 1. So my slope is -1 over 1. My y-intercept is -1 also. So I'm going to go down 1, make a point. And from here, I'm going down 1, 1 to the right. Down 1, 1 to the right. Down 1, 1 to the right. Or up 1, 1 to the left. 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 It's going to be a solid line this time. So let me draw my solid line here. Okay. There it is. And now I'm looking for where y is greater than. So that's going to be shaded above the y-intercept, greater than. So I want to go above the red line and above the blue line. Above the red line and above the blue line. So red line would be shaded up here. The blue line would be shaded up there. So above the red line and the blue line will be in here. And there's my solution. And again, if you have trouble with that, you can graph, you can certainly shade both lines in, okay, both solutions, and then pick out where the two shades come together. All right. So now, it wants us to circle any of these points if they're solutions to the system. -4, 1. So if we go left 4 and up 1, no, that's not in both shadings, in the shadings, so that's not right. 2, 0. Nope, that's not right either. 1, 4, right 1, 4 to the right. Or I'm sorry, right 1, 4 up. Yep, that point right there, that's in the shading. So that is the only point here that's a solution to the system. There are a lot of points that are solutions to the system. Okay, so like 0, 4 is a solution. Anything that's in the shading here is going to be a solution. -1, 3, 3, 5. Okay, anything that's in the shading will be a solution to the system. It'll work in both equations. All right, and one more. So let's try the first one here. X plus 2y is less than or equal to -6. So x plus 2y less than or equal to -6. We got to solve this for y. It's a positive x, so we'll move it by subtracting it. 2y is less than or equal to -6 minus x. Divide everybody by 2. We have y is less than or equal to -3 minus 1 over 2x. My slope is -1/2. My y-intercept is -3. I'm going to start by going down 3. Then I'm going down 1, 2 to the right. Or up 1, 2 to the left. It's going to be a solid line. All right, and let me look at that y-intercept or the slope-intercept form. It says y is less than, so I would shade down here in blue. Anywhere down here would get shaded in blue. Okay, and then my other line is x is greater than -3. All right, well then I'll do that in red. Okay, greater than -3. So that's got to go through the x-axis at -3. It's going to be a dashed line. There it is. And it's going to be greater than -3. So anything to the right of -3. So that's all this. All of this is to the greater than -3 and that. Okay, so where are the two shades together? They're together down here in this region. So that's where my solutions lie. So everything else, all the other shading I'd have to erase. Okay, so this is how you can do it if you want to do it with the two shadings. All right, just erase all that. And there's your solution there. Okay, and that's how you would do this. All right, it's very, very similar to what we just did. Okay, except you're doing two on one graph. All right, now here's a couple for you to try. Here's the first one. Okay, please note that the shading that's here in A, B, and C is the shading where both shades are. Okay, it's where both of them are being shaded in. All right, okay, they only shade where it's been shaded for both inequalities. Okay, and then we have one more. All right, now for this one, they want you to pick the inequalities that make this graph work. Okay, pick the two inequalities that make this graph work. So there will be two answers here. All right, pick them both. Okay, all right, that's it for today. Thanks for clicking.